Hi everybody, thanks for joining today's webinar. Today we're going to be going through a sample analysis focusing on the Harmonized Share from the Gateway to Global Aging data. We'd like this webinar to be interactive, so if you have any questions or comments during the webinar, please feel free to use the question box or the chat box. There's also a handout provided for you, which is called Advanced Share Webinar May 2018.doc. You can download that in the handout section of the GoToWebinar panel. That's actually a Stata.do file, so you can download it and remove the C from the extension and run it in Stata. So now we're going to go ahead and get started. So we're first going to do an analysis using the Harmonized Share. Then we'll be comparing the results to the United States using the Harmonized HRS and the RAND HRS. The RAND HRS has existed for years and offers an extensive number of variables in a variety of domains. The Harmonized HRS was just released about 2 months ago by the Gateway and is meant to be a supplement to the RAND HRS, having variables that the RAND HRS doesn't already have. So we're going to pick a research question to start with and get a feel for using the Harmonized Share. So we're going to be asking, are there country differences in mobility difficulty, and are there differences across different education levels? So right now, we'll be looking at the 18 countries that participated in the share in 2015. I know that's a large number, but there are over 30 countries that have harmonized data through the Gateway to Global Aging, so you could compare a lot more. We'll be creating a measure of mobility difficulty, which adds together each activity that someone reports having difficulty with at the present time. Our measure of mobility difficulty includes lower body activities, like walking 100 meters, going up multiple flights of stairs, getting in and out of a chair, and stooping, kneeling, or crouching. And it includes upper body activities, like extending your arms up, lifting 10 pounds or 5 kilos, and picking up a small coin. And we'll be looking at mobility difficulty across education levels to see if it explains the differences that we see. So the steps that we're going to go through first are we're going to create the Harmonized Share dataset, and we're going to identify the relevant variables. We're also going to create some new variables, mainly our measure of mobility difficulty, and save our example dataset for use later. Then we're going to apply weights and start looking at mobility difficulty across countries and education levels. So the first thing we're going to need to do is download the Stata data from the Share Research Data Center. If you'd like a direct link to the website, I suggest you visit the Gateway to Global Aging data. This can be reached at g2aging.org. That's the website that we maintain. It's a centralized resource for researchers looking to use these harmonized studies. Before you can download the data, you'll need to register for the share and for each HRS sister study you're interested in. Let me take you to our downloads page. To register, you can go individually to each website using the links provided here. Or you could use our brand new Universal Access to Study data. You can select which studies you want to register for and get most of your registrations done at once. If we go back to downloads, so once you've registered and downloaded the share data using this link, we're going to download the Harmonized Share creation code from the 4th row of the downloads page, and the creation code is great because it allows you to see exactly how the variables were created. Just so you know, the creation code was updated just last week to account for Share's 6.1.0 release that happened at the end of March. So this is what this data creation code looks like. And we'll just need to change the folder locations where to where your data is actually saved. And when you do this, make sure to remove the pipes from inside of the quotation marks. After editing the folder locations for the original share data in the creation code, we can run the code and get our Harmonized SHARE dataset. And you can go back to the gateway and download the Harmonized SHARE codebook, which I'll show you how to do in a few minutes. Next, we'll want to identify our variables of interest. And since we'll be comparing it to the HRS later on, we want to make sure they're comparable. It can be a task to find different measures that are comparable. So you could download the study questionnaires and look through them, but we also have a built-in search function to the gateway to global aging data and a couple other helpful features for finding these comparable measures. So if we jump back to the gateway website and select documentation on the upper left, you'll see that we have many different domains. And these have tables showing comparability between different studies. So we're going to be looking at health and at functional limitations. And here we're looking at some of these functional abilities. And we see that the HRS and SHARE have several of these in common. And there are other tables like these two and many others on the website. So this can be a helpful place to get started. Then, under the Concordance tab in the top middle, we have a search function. So we could type in a search term here and even select the studies and the years we're interested in and hit search, and we can get information on variables from the original studies. Or we can search for this using the harmonized data instead of the study data. So if we select the Harmonized SHARE in the year 2014 or 15, and we look at the other functional limitations under the Health tab, and scroll down and hit search, we can get all of the functional limitations from the Harmonized SHARE in 2015. You'll see the variable naming convention is pretty simple. So the first letter in the variable is either an R or an S or an H, meaning the respondent, the spouse, or the household. The following number represents the wave number. So for the SHARE, these are wave 6 variables. You can click on any of these to find out more information. And then we also have the harmonized codebooks, which provide a lot of information. So I'll quickly show you how to download the codebooks. We're going to go back to the Downloads tab. And on the third row, you can download a codebook from any of our harmonized datasets. We offer codebooks for all of our harmonized datasets, so I'll pull up our Harmonized SHARE codebook now. As you can see, this is version D.3 as of May 2018. And you can use the bookmarks on the left to, for example, select other functional limitations. As you can see, we have the name for each variable with labels, and we offer some brief descriptive statistics. And you can learn more about how the variable was created in the How Constructed section. And you can also we also highlight any differences between waves and any differences between the Harmonized SHARE and the RAND HRS. We always use the RAND HRS as the basis of comparison when creating the harmonized datasets. So if we go back to our research question, we're going to look at mobility difficulty across countries and education levels. So we'll need to identify our selected variables from the Harmonized SHARE, and you can do this using the codebooks or the concordance search, both available from the Gateway website at g2aging.org. While SHARE and the HRS are longitudinal studies where they go back and re-interview people on an ongoing basis, we're going to be doing a cross-sectional analysis, meaning looking only at 1 year or one wave. So for our year of interest, we're going to look at 2015, which happens to be the 6th wave of SHARE, to do a cross-sectional study and sort of get a snapshot of mobility difficulties. For SHARE, the person identifier is called merge ID, and the components of our mobility difficulty variable will be R6, walk 100A, chair A, climbs A, stoop A, lift A, arms A, and dime A, which correspond to walking 100 meters, getting in and out of a chair, climbing several flights of stairs, stooping, lifting about 10 pounds, extending your arms, and picking up a small coin. We have our country variable called ISO country, the respondent's age in 2015 called R6 age Y, whether they participated in the 2015 wave called INW6, and education level, which is RAED-UCL. So this variable is divided into 3 categories. The lowest is less than upper secondary, the middle is upper secondary or vocational training, and the third is tertiary education. And last of all, we have our individual analysis weight in R6 weight RESP. So we're going to go ahead and start to use Stata now. And remember that in the handouts we have that .doc file, which is really a Stata do file that we're going to open up. So we'll open that up in the do file editor inside of Stata, which is this little notepad with the pencil here. If you're unfamiliar with Stata, sorry about that. If you're unfamiliar with Stata, I'd encourage you to follow along. A lot of the commands will be similar if you're using a different statistical package like SAS, SPSS, or R. We do have some samples of a similar analysis in SAS that we provide, which I'll show you how to find at the end of the webinar. So I'm going to open this program. Called Advanced Share Webinar May 2018.do. And if you're following along, you'll need to edit lines 5 through 8 to say what folders your data is coming from. One other thing you'll notice in the program is a command called pause. So once we start to run the program, the pause command will stop it at different points so we can look at the output that Stata has given us, then continue to move on. So we can execute or run this do file by clicking on this icon with the arrow on the top right. So Stata has run the do file to our first pause, and when we're ready to continue, all we need to do is type Q and enter, and the program will continue running. So I'll bring up the commands on the slides where it's a little easier to see, then we'll jump back to Stata to look at the output. So the first thing we want to do is read in the observations and variables from the Harmonized Share. We employ the command use because we're going to use this data set and bring it into Stata. Stata works by building a data set in its memory, which makes it fast, but it needs to be brought into Stata memory first. So we're going to use the variables we identified using the Harmonized Share d3.dta. So if we jump back to Stata, sorry, 1 second, please. Let me just try to open this file again. We seem to be running into some technical difficulties. Okay, great, we got it working. So we can see that we have read in the variables, and we did a quick tab for ISO country. You can see that we have over 68,000 observations in this wave of share from Austria down to Switzerland. So we're now going to create our measure of mobility difficulty. To do that, we're first going to create a variable indicating how many of our component variables are missing data. So we're going to useegen, which is an enhanced generation command as compared to gen or generate. And we're going to make R6 mobile sev m to calculate how many of our component variables are missing data. The row miss term says to add one if any of the variables inside the parentheses do not contain a value. And we're adding an if statement so that we only calculate the missing score if they participated in the 2015 wave. Once we have that, we'll use it to calculate the variable we're actually interested in, which is the number of mobility difficulties. To do that, we'll useegen again, and this time we're going to be creating R6 mobile sev, and we're going to use row total, which says to add up the values of the variables inside the parentheses. But we're adding another if statement so that we don't add up values if all of the component variables are missing. And the comma m at the end of the statement allows the command to calculate values for R6 mobile sev even if some of the component variables are missing. So we'll go back to Stata and press Q and enter. And we can see that we've just created those new variables. We've done a tab for R6 mobile sev, and we see that everything looks on track. Just over the half of the respondents have no mobility difficulty, and the rest range from having 1 to all 7 mobility difficulties. So now that we've got those set up, we'll save our current data set to use again later, and we can move on to our next step. So we're going to apply weights. And one of the helpful things about using Stata is they have a lot of built-in commands for using survey data. One of those commands is called svy_set, which tells Stata how this complex survey is set up. This allows us to tell Stata how the data is weighted. Here we're using the combined person weight provided by the Harmonized SHARE R6 weight resp. And we can also tell Stata about how the sample is stratified or clustered. So in this case, we're going to say that our strata is at the country level. So our weights refer inside of each strata or each country here, and we can end up with national level estimates for each country. Once we enter this svy_set command, we don't have to specify these things for every single analysis command that we make from here. Instead, Stata will recall this information. So we go back to Stata. You can see we've just run this command, and we've also run a command called svy_describe, so we can describe our sample. You can see that we have a total of 18 strata here, corresponding to the 18 different countries in the SHARE 2015 wave. So I think before we get into anything more involved, we should first just look at the mean count for mobility difficulty for the entire SHARE sample. So to recall the svy_set information that we gave Stata about our survey design and how we want our estimates weighted, we're going to say svy, which tells Stata to recall what it was already told. Then we ask for our mean of R6 mobile sev m. Within Stata, we get a mean of 1.29 for all of our SHARE countries. But what if we only want to look at one country? Then we'd want to set a subpopulation condition. And this is extremely important inside of Stata to get correct errors. So if we set our subpopulation by saying if the ISO country equals 620 for Portugal or 756 for Switzerland, for example. This lets data know which standard errors are applicable and which can be ignored. If you were to put an if command after the mean statement, this wouldn't estimate the standard errors correctly. So this is the right way to do it. So let's actually see what this looks like in Stata. So we can see our weighted prevalence estimates for Portugal and Switzerland separately. We can see that Portugal has a mean mobility difficulty of about 2.01, and Switzerland has a mean of about 0.68. But if we remove the ISO country from the subpopulation condition and instead put over ISO country after the mean statement, we can see all countries in a single statement. So let's see what this looks like. You can see that Stata tells us who is exactly in each subpopulation. In addition, we see the mean, the standard error, and 95% confidence intervals. And this can be really helpful if you want to know whether these are meaningful differences. But let's look at this visually. We can see quite a bit of variation going on in these European countries plus Israel. Only a few countries have an average mobility difficulty of less than 1. Most are between 1 and about 1.5, and there's only a few going over that. We can see that Portugal has the highest mean and by far the biggest confidence interval, while most other countries have smaller, similarly sized confidence intervals, and it looks like Switzerland has the lowest mean. And if we want to test whether two countries' estimates are significantly different, we can use a command called test, which is called a post-estimation command, meaning you run it after you've created your estimates. Here we've created mean estimates of mobility difficulty by country. So if we run this and test for a difference between subpopulation 14, which is Portugal, and subpopulation 18, which is Switzerland, Stata will perform an adjusted Wald test. We'll see that the probability greater than the F statistic is 0.0000, which is statistically significant. But we're interested in seeing the impact education has on mobility difficulty. This command is going to look very similar to the previous command, but we'll be adding our education variable to the overstatement to look at the mean by country and education level. So if we do this, we can see that Portugal is subpopulations 40 to 42 and ranges from low to high education, and Switzerland is subpopulations 52 to 54. So this means that people in Portugal with the lowest level of education have about a mean of 2.17 mobility difficulties. And Swiss people with the highest level of education have an average of about 0.41 mobility difficulties. And if we want to test whether the differences are statistically significant, we can use the test command again. If we test between the least and most educated groups in Portugal, then we use subpopulations 40 and 42. And if we test between the least and most educated groups in Switzerland, then we use subpopulations 52 and 54. And if we run these tests in Stata, we can see that there are statistically significant differences between the least and most educated in Portugal and in Switzerland, though the difference in Switzerland is a little more significant. So let's look at the mean mobility difficulty for these two countries graphically. We can see that Portugal and Switzerland both have step-down patterns, though there appears to be different spacing between different levels. We can also see that Portugal's confidence intervals for the two higher levels of education seem very large. Switzerland's confidence intervals are much more consistent, and their estimates seem to be much lower than Portugal's. But now it's time to ask a new question, and that is, how does mobility difficulty in European countries compare to mobility difficulty in the USA? In order to assess this, we're going to have to prepare an HRS dataset. So after you've registered for the HRS, we're going to download the Harmonized HRS and RAN HRS. The links for these can be found on the download page on g2aging.org. Then we're going to identify the relevant variables from each dataset, merge them together into one HRS dataset, and save this example dataset. After that, we'll pool our observations from SHARE and the HRS to create a single analysis dataset. We'll prepare our variables, apply our weights, and finally analyze mobility difficulty across countries and education levels. So after downloading the Harmonized HRS and RAN HRS, we'll identify the variables we need. First, we'll look at the Harmonized HRS, which is meant to be a supplement to the RAN HRS and contains variables that the RAN HRS doesn't have. The 2014 year of interest will be comparable to SHARE, which happens to be wave 12 of the HRS. The person identifier in the HRS is HHIDPN, which we'll need to use to merge with the RAN HRS. Then the count of mobility difficulty has already been created here and is called R12 Mobile Sev. In the HRS, this includes difficulty walking one block, getting in and out of a chair, climbing several flights of stairs, stooping, lifting about 10 pounds, extending your arms, and picking up a small coin. And we have the respondent education level, which is called RAED-UCL, the same as it was called in the Harmonized SHARE. Then we'll look at the variables we need from the RAN HRS. We'll need to use the HRS ID variable again, and we have the respondent's age in 2014, which is called R12 AgeY_E, and the respondent analysis weight, R12 weight resp. So the first thing we want to do is read in the observations and variables from the Harmonized HRS. Once we do this, all of our SHARE data will leave the temporary Stata memory and we'll call it back in later. So we're going to employ the use command, again, to get our variables from the Harmonized HRS. Then we're going to merge those variables using the ID variable HHIDPN, using the RAN HRS dataset, and we're going to say that we're going to keep using a few variables, in this case the weight and the age variable. The keep command isn't required, but it is helpful if you don't want to read in the entire dataset, which can be extremely large. Just reading in your variables of interest will help keep your data processing quick. Then we're going to generate the ISO country variable, which will tell us what country these data are coming from. In this case, we're using the 3-digit numeric ISO country code for the USA, which is 840. So all of the observations currently in the dataset, which we know represent the US, can be identified easily. Now if we go back to Stata and we continue our program, we can see that over 37,000 observations have matched, and we now have our merged HRS dataset. So we'll save this and start combining our HRS and SHARE datasets. To create our pooled dataset, we're first going to use our prepared SHARE dataset, which we saved earlier, called Harmonized SHARE Example.dta. Then we're going to read in our prepared HRS dataset. And to do this, we're going to use the append command. We're not using the dataset again because that would replace our current SHARE dataset. And we're not merging because we know that there won't be anyone in common between the two datasets. So we're going to append the new observations, which will put them below the current dataset. So we'll append using our HRS example dataset, and we're going to generate a variable called append, which will let us know if the observations are coming from the HRS dataset because it was appended, or if it was already in the SHARE dataset. Then we're going to recode the append variable, making the zeros equal to ones and the ones equal to twos, and generate a new variable called study. Then we'll name the values of the study variable so that 1 means SHARE and 2 means HRS. This will be helpful when we prepare our variables. So if we jump back into Stata, you can see that we've done this and typed in a tab for study. You can see that we have over 68,000 observations from SHARE and over 37,000 from the US. So we know that we have data from both studies in there, and we have our pooled data set. The next step we're going to do is prepare our variables. You may have noticed that the variables from the harmonized datasets contain a wave number, and this is particularly helpful if you're only looking inside of one study. But when you want to compare between different studies and you want to compare the same years, you're most likely going to need to create some new variables to make up for the different waves between studies. So we're going to make some new variables based on the year and not on the wave number. Our first variable will be our 2014 mobile SEV, so we know that the values will come from R6 mobile SEV if it's coming from SHARE, which is marked by study number 1, and from R12 mobile SEV if it's from the HRS, which is study number 2. So we're also going to take the same steps and create our 2014 age Y for age and weight 2014 for our person level weights. So once again, we're creating new variables based on our year of analysis rather than the wave number, and that contain observations from the SHARE and HRS datasets. If we type Q here in Stata, we've just created those new variables. Now that we've got those set up, we can move on to our next step. So we're going to apply weights using the SVY set command again. And this time we're going to be using combined weight 2014 that we just created and setting up our strata as isocountry. So let's do this inside of Stata. And you can see that we've used the SVY describe command again. And we now have 19 strata here because we had 18 from SHARE and now 1 representing the US. So we're going to estimate our mean mobility difficulty using all the countries in SHARE and the HRS. So we're going to include SVY to recall our earlier command for weighting the data. Then we're going to ask for the mean of our 2014 mobile SEV over isocountry. So if we do this in Stata, we now have 19 subpopulations. And we can see that America is now the last one. So the mean mobility difficulty for Americans in our sample is about 1.83. So let's look at this visually. So we have the same European estimates that we saw before, but now we see the USA included on the far right. It's pretty clear that the mean mobility difficulty for the US is higher than almost all of the share countries, with the exception of Portugal. We can also see that the USA's confidence interval is pretty small due to its large sample size. Now we're going to add our education variable in the over part of our command to obtain an estimate of mean mobility difficulty by country and education level. So if we do this in data, we can see that the American education levels are at the very bottom. So we can see that the least educated Americans have an average of 2.8 mobility difficulties, and the most educated Americans have an average of 1.2 mobility difficulties. And if we want to test whether this is a statistically significant difference, we're going to use the test command again. This time we're referring to subpopulations 55 for Americans with the lowest level of education, and subpopulation 57 for Americans with the highest level of education. When we enter this command, we get a probability of 0.0000, so we know that this is a statistically significant difference. And now we can see how mean mobility difficulties vary by education for Portugal, Switzerland, and the US, all in one graph. The USA also has a step-down pattern, and its variability lies somewhere between the other two. And we can see that the overall means seem to be a lot higher for the US, even compared to Portugal's first two education levels, when we've before learned that Portugal has an overall higher mean than the US. We also see that the confidence intervals for the US are pretty similar and probably smaller than that of Switzerland. So that's going to wrap things up. If you ever have any questions or comments, please visit us at g2aging.org or email our help desk at help@g2aging.org. We can help if you have some specific questions about a harmonized dataset, or are having difficulty finding something, or in figuring out how to get started. I'll also mention that the slides, a video recording, and the stated code from today's webinar will be available on the Gateway to Global Aging website in the next few days, in case you want to watch it again or send it to a colleague. So this can be found on the Documentations page under Recent Presentations. And if you're looking for an example of an analysis using SAS, I suggest you check out the SAS code from the March 13th webinar featuring the Harmonized HRS. So we want to thank you for joining today's webinar. We hope you find the harmonized datasets useful. After the webinar, you'll be sent a short survey where you can provide feedback or tell us about what topics you'd like to see in future webinars. We are always trying to improve our offerings to be relevant to you, so please fill the survey out. I'm now available to take any questions that you might have, which you can do in the chat window or by using the question box. You can also raise your hand and I can unmute you and you can ask a question.